Can everyone hear me? Is that hear me? Yeah. So hey everyone, I'm Adrian. I think thanks for coming on a Friday night. I think that's quite a lot of you. I'm from NTU and I don't think like we have the kind of culture, so I think and that's very great. But yeah, I think hope you all have your pizza and your bounty. And today I'll be sharing about how the tips and tricks that we use to scale our platform to like 400K monthly visitors. Yeah, so a bit of introduction about me, right? So I previously co-founded NodeFlair. It's a Series A company based in Singapore, and we expanded to like more about 8 countries throughout the years. So for those that don't know, I think NodeFlair is a platform where like users can like research about companies' information like salaries, reviews, jobs, all this kind of like Glassdoor. But I think what we were trying to do is like I would say trying to make a more trustworthy Glassdoor, better UX, and also much more localized for the Singapore and Southeast Asia market. Yeah. So I think a bit about us, right? I think previously I'm the only like full-time engineer. So kind of means that I have to do everything, like back-end, front-end, DevOps, everything. And also at any point of time I kind of have 2 to 3 like engineering interns helping me to get extra hands to build some of the features on the site. So I think they're also for NUS. So yeah, really great folks, right? Yeah, I think that's one of the limitations, right? Oh, it's like what is it now? Is it? That's right. Yeah. It's on another screen. Yeah, we go on internet. Okay, thanks. Yeah, so I think back to the point, right? I think I'm the only full-time engineer. There's a lot on the plate. So not just like doing like ICU, but also like hiring and managing the interns. And also on the other hand, I think at a startup, there's a lot of things we really want to do, right? So like we really want to experiment, do a lot of things, try a lot of bets to see what really works. So there's a constraint in terms of like both I would say time and also I think mainly time. But also I think as a really small startup with not much like fundings, we also have to be very prudent with how we do things. So for us, given the cost, we managed to achieve all that with monthly infra cost of less than $500 per month. And that's include everything, right? From your server to your database to your cache to your Elasticsearch and everything. So I think to be very like simply put, like we are very resource constrained. So I think to make this work, right, try to achieve this kind of scale with so little resources, I think there has to be some like principles around how we do things. And I think to sum it up very simply, right, what we kind of realized over the years is that I think being very pragmatic is kind of the way to do things. Because I think a lot of times, nowadays when you see a lot of the startups, they kind of try to use very, I would say, tools that are very good, but probably too much for what they need. So kind of like an overkill, right? And I think being boring is kind of, in my opinion, it's a feature and not a bug, especially when you need to do so much, right? So for example, when we onboard like interns, we want them to be start like delivering as soon as possible. So by nature of the simplicity of the stack that we use, most interns actually shoot their first PR within the first 2 to 3 days. So that's kind of the goal that we achieve with the simplicity and pragmatism. Yeah. So I think about our company, right? So there's five things that I can share to give about some of the context regarding how we approach the challenge. So I think firstly, right, fundamentally, the platform is a content site with a lot of web pages, right? So there's like more than 2 million web pages in terms of like salaries, companies information. So with so many pages, what it brings about is also a lot of like bots and like scrapers or crawlers. There are good ones and the bad ones. Right? So the good ones are your Google bots that help you index your page and rank on Google search. And or there's ambiguous one like maybe your LLM bots which trying to train on your data. And there's the obvious bad one that are like trying to do like some SQL injection, trying to like find security vulnerabilities, right? But fundamentally, with so many pages, the site visitors they are both like bad bots and actual users. So the second part is that it's a very read-heavy application. So unlike your e-commerce site where like there's a lot of like write transactions, I think for us, most users just consumes the information. So with that, it means that egress is very expensive. So for those egress is basically like data leaving your devices, like your servers and your database, right? So egress was half of our cloud cost at some point of time, which I will share later how we managed to reduce that. And I think the third point is that being a very consumer-centric kind of platform, users expect to be fast, right? So for context, like about half of the mobile sites visits are abandoned if like the initial load time is more than 3 seconds. And I think having considered that our platforms are also serving users from like the less developed countries with mobile devices that are not as good or internet that's not as good, I think speed is becoming increasingly a challenge. And so I think another example is that I think for Pinterest, right, when they rebuild their websites, they realized that by reducing the wait time by about 40%, they see about a 15% increase in SEO traffic. And I think for content sites that monetize by like advertising and like users' activities, any like more traffic is a good thing. And number four is global users, right? So we only focus on like serving like users in like Southeast Asia and this part of the world. There are also going to be users that comes from outside of like Singapore. So maybe someone in the US trying to look for a job in Singapore. So you also come to like research about like Singapore companies. So we also have to take into account that there are also global users that how can we have them have the similar experience even though it takes time for like data to travel halfway across the world. Right? And I think the last part is really the data intensity part of like NodeFlair. I think one of the features or product that are really popular is like NodeFlair service where people can research about verified information. And that part of time, I think we have about 6 million plus data points. And I think the question is that given this 6 million data points, how can we then have like milliseconds kind of like load queries and search time? And I think that's one of the challenges also. Okay, so before I share about the tips and tricks that we use, I think the heads up, right, is that a huge disclaimer is that one size doesn't fit all. So it really depends, and it really depends on the nature of your application and how you want to make some compromise about it. And I would also say that before I start NodeFlair, I didn't really work at any like bigger companies before. So a lot of the things I kind of have to figure out myself. And they might not be the best practice, honestly speaking. And also, but at least for us, it works. And I think also a lot of things regarding this kind of like tips and tricks also about the context, right? So whatever works for us like today might not work for us like 3 years down the road when there are more users. So it really depends on context. Okay, so I think here's the part, right, like how it started. So usually very simple diagram that I think most of you are very familiar with. Like users come in, the server fetch like information from the database and then returns to the users. This is kind of like how it always started. So but the challenge is that almost every part of this process is very expensive. Like hardware are expensive, egress are expensive, everything is expensive, right? So how do we then go about solving it? Yeah, I mean, of course you can just throw money at it, right? But I think technically you can scale it very easily if you just throw money at it, but I mean, if that's so simple, then there's no point for the talk, right? So the question is that if you want to build something today with limited resources, how can we then approach it in a more pragmatic way that don't just burn money? So the first point that we have, right, is that we first of all we put a Cloudflare, which is they have Cloudflare has different part of it, but I think the one that I'm talking about right now is the firewall and the DDoS protection. So initially when we first implement Cloudflare, with just a few settings and within a few settings, we managed to reduce the number of bad bots by about from 25% to 5%. And then from there, we really look into the kind of requests that we have, right? We have we always see a surge in traffic from these particular devices at this particular time, or from this weird user agent in the browser. So from there, we further fine tune the firewall rules, and then we reduce it to 1%. So with this, we basically don't really serve 25% of the traffic, which means technically kind of you can think of 25% cost saving. So that's a win, very good win. And number two tips, right, is just put a CDN to cache everything, right? So initially when we first add a CDN aspect of things, we see that about 50% of the requests are cached right out of the box. And then we further look into what kind of requests can be further cached. And so what it means that when a request is being cached as a CDN, we set off a layer in front of our servers. The requests don't even hit our servers or our database, and they are served from the CDN itself. So when requests don't hit the database, you don't have to serve those requests. It means you don't really need as much servers at all. So that's a lot of cost saving. So for context, right, I think by saving this 95%, we are saving about 1 terabyte of data from being processed on our own servers every month. So that is the kind of cost saving that we are talking about. And I think another point is that CDN, something that we also sort of unexpectedly realize is that CDN sort of help you in the case of DDoS. So let's say someone decided to try to take down our server, and it just happens to hit requests that can be served from the CDN. Even if the firewalls and all the DDoS protection fails, you don't really pay for it. You don't pay for any of it. You just serve from the CDN. Yeah. Okay, so the third part is something that's a bigger topic. It's about optimizing the database, which is something that is much more relevant for our context. So when it comes to saving costs on a database, or even choosing how do you want to run your database, generally there's two approaches. One is the fully self-managed one where you buy a server and then you try to manage everything. If it goes down, you handle it. If you lose the data, you're fucked. There's nothing that you can do, but you really have to do everything by yourself, right? And there's another part which is that, okay, maybe you can use some of managed database, like your typical cloud services. So it kind of really depends on what you want to get out of it, right? But I think from doing my own readings and really everything, at a small scale, it really doesn't really make sense to run a self-managed database because there's so much things that can go wrong, and it's not worth your time to do that. And even one of the providers Fly, even though they help people set up self-managed database, even the CEO himself says don't use that, even though we have this product, don't use this product unless you really know what you are doing. So yeah, I think for the most part of people, just choose a self-managed database. But I think choosing not choosing a self-managed, just choose a managed database. And I think choosing a managed database, there are also a lot of things to consider because there are so many things that can actually goes into the cost of a managed database, right? So for example, I think there's different way of charging. So it's usually make up of a variety of costs egress, storage, like the number of like CPUs, all this. So you kind of have to really do what makes sense for you. So after consideration, right, we switch to this country bridge, which is sort of, I know a lot of people know about this provider, but they actually do quite a good job in managing like Postgres, which is what we are using. And for them, they also been in the business for like 10 plus years. So we don't have to worry about, let's say they're going to shut down tomorrow, and then we have to like scramble to like migrate our data to another place. And they are hosted in Singapore, which most of our users are, so we should have like minimal like latencies. And also, they don't have like real requirements. So for example, I remember like we were deciding between using like Country Bridge and also DigitalOcean. And then DigitalOcean have this very like unreasonably like weird kind of like maximum number of connections per like database. And so those are the like things that is going to catch you off guard, right? But yeah, given all these considerations, we actually decided to go with Country Bridge, and because they don't charge for egress, which is what a lot of our costs are, we actually save about half of the database cost. Okay, so the number 4 point on optimizing database is really adding indexes. It sounds boring, and it is boring. Like don't get me wrong, right? But I think sometimes like the boring solutions are the one that like really get you to like it's the fundamentals, right? So yeah, I think we saw that some of the queries are having a lot of like latencies or taking a lot of like database load. So we just add some index, find which columns are being used for like filtering, for ordering, for like joins and everything. And we managed to cut down the CPU load to almost nothing just by adding indexes. And tips number 5, right, is about how we can cache the queries that are commonly being fetched or used. So, for example, right, if today, this is one of the example of one of the company pages on our platform, and you can see that we have this sort of like navigation bar for each company. We show the number of like salaries, reviews, jobs, interviews, questions. And so these are something that is going to be consistent for the company for, I would say, quite like, it doesn't really change that often. Maybe it changes once a day, but it doesn't change that often. And what we realize is that if someone today I'm looking for a job at like Grab, I'll look at the salaries, sure. But I'll probably also look at the jobs. I'll also probably click and look at the reviews and interviews. So what we were doing beforehand is that every time we go to a different page, we compute this data again. And so if someone today goes to like 30 different pages of Grab, we actually load that data 30 times. And realize that that really isn't necessary, right? Because even if it's off by like, numbers off by 2, like it doesn't really affect the user experience a great deal. So for us is that, okay, how can we then cache all of this information in Redis so that we don't have to hit our database, our Postgres database. And also because like Redis is much faster than like Postgres, we also can speed up the page load of the website. Yeah, so by caching those requests and they don't even hit our Postgres database, we realize that we managed to cut down like also all the like CPU loads that is happening on our database. So to compare, right, I think if we compare the simple stuff like just adding indexes and caching some of the queries, we managed to actually reduce a lot of the load time to like just 100 milliseconds to 250 milliseconds. And I think that's quite okay. I wouldn't say it's the best, but I think given that the data intensiveness nature of the platform, I do think that that's quite possible, at least to end users. Yeah, and I think they are very simple, low-hanging fruit that I mean, you probably learn in school like these kind of things. So yeah, with less database load, we actually don't need such a big tier of database. Like we can use a less CPU, and overall it will scale much better. Okay, so number 6 point, right, is actually this concept of like materialized view in like Postgres. So just an example, right? So today, if I want to find out, like, I want to get everyone here who the birthday starts in like January. What we are doing beforehand is that I will have to go to everyone and says, it's your birthday in January, it's your birthday in January, it's your birthday in January, and it has to go on for maybe like 60 of you. So what we realize is that in Postgres, there's this thing where we can pre-compute this data, and so that when we have to look for something, it's much faster. So kind of like a table of content kind of thing, right? So in this case, I ask each of you when's your birthday, I write it on a piece of paper. If someone needs to know like, okay, whose birthday is January, I just have to look at my piece of paper. I don't have to check every one of you. So that actually cuts down a lot of time. But eventually, that's still not like going to scale at some point, because if it's something that's like not like birthday, right? It's something that changes. It means that I still have to update this very frequently. So instead of like asking what's your birthday, and I want to ask like, oh, what's your GPA, and it changes every like semester, right? So I actually have to update this like every semester. So and if it's something even more frequent, I have to update it more frequent. And the thing about like trying to store this beforehand is that, first of all, this data might be outdated, and whether you can sort of risk having it outdated. And the second point is that, let's say I'm compiling like all your GPAs, right? When in my compilation period, when someone can ask me, so whose GPA is like above 4.5? I couldn't tell that person because I'm too busy still compiling your GPAs, right? So there's sort of like database log kind of things that happening in the background that is stopping us from like scaling. So what we realize is that, okay, wait a minute, like if today I want to find the GPA of everyone in this group, I actually don't have to ask each of you every single day because the GPA is not going to change every day. Instead, I can ask you every like semester instead. And what that translates for us in NodeFlair, right, is that for the salary data on the platform, instead of like trying to compute this every time someone trying to ask for it, right, we actually just have to compute it like every hour. And even I will argue that every hour is probably too much, but I think that's fine. But just the act of like having this like computation beforehand and understanding that, okay, what's the frequency of refresh of this data, we're actually able to cut like the database load by another 65%. So overall, right, if you look at the entire picture, we actually cut the database load by a total of like maybe like 75 to 80% just with these few tips and tricks, and it has close to zero like impact to the end users in case of experience. And I think this is a part where it comes to making, I would say, very strategic trade-off in terms of product, because I think in the ideal world, everyone wants data to be 100% like real time and updated. But I think what schools don't teach you all is that in real world, a lot of times you can actually make some compromise, and you can actually save a lot of costs while still delivering the same value. And I think it's especially important nowadays with like, I mean, if you're not ASR, you probably don't get funding, you probably have to save a lot of money and not spend it, right? So yeah, I think just really balancing between what's ideal and what's practical. So overall, right, with the kind of strategy that I mentioned, we actually save a lot of money overall, and not only is it cheaper, but everything is also like much faster. So I think the conclusion overall is that yes, you can always just pay AWS like 2 times more, 4 times more, but maybe you don't need it. I don't know, like that's just my experience. Okay, so from this point onwards, it will be some tips on like, so previously what I was sharing is like, what is the actual like speed that the application is. But what I'm going to share is that, what is the perceived speed that the users sees. Because I think there's a difference between whether something is fast versus someone thinks you are fast. So one of the example is that for us when we want to share, like when every like job listing page there's this like share icon which like also have this like this image or like for people to share. This image is actually not being seen by most people unless they click the share icon. So we actually don't have to load it like beforehand. We don't have to let it, because typically if you don't declare anything, it will be loaded and then you will block everything else from being loaded. So by actually just having a like lazy loading, we can actually like not have it be the priority in terms of like the network loading. And users wouldn't know. Like nobody would know about this. But to them it's just this website is still fast. And also what happens is that I think this is a bit more specific to like Ruby on Rails, but what I'm trying to say here is that what to users, how do they perceive a website is fast, right? Is that when I click on the link on Google or when I enter a URL, how long does it take for me to see something? So I think for like core web vitals in your like Google, like how Google ranks website is I think one of them is called like time to first byte. And what we can do is that actually, let's say your page has like multiple information, you don't actually have to compute all of them at first. What you can do is you can render a sort of like a blank template for the users, and then you subsequently load the data in some of like spinner or whatever. And to the users, as opposed to saying I click on this and it takes 1 second to load, they will see is that I click on this, it takes 100 milliseconds to load, but the data comes in after that. And I think that's good enough for them, and they feel that it's faster. So that's what's important. So overall, right, I think to sum it up, there's a few things that we can do over here to really to scale a platform to serve more, achieve more with much less. So I think throughout the times, I think there's also a lot of mistakes that's being made. I think this is something also more specific to Ruby on Rails, but I think one of the mistakes is really not understanding the framework enough, right? And as simply put, it's a skill issue. So what you do is that you actually go and read up to understand what's the underlying like documentations, right? I think documentations they are actually useful if you go and read them like from time to time if you really want to be like good at what you do. So one of the examples that we really had, that really made a mistake was that I set the number of threads too high. So to me at first it's like, yeah, more threads means more things get like served concurrently, right? That sounds perfectly logical. But apparently this max thread like variable is extremely, I would say, misleading to people if you don't read the documentation. Because what it really means is that today let's say I have a restaurant and I have like 10 tables and I have a waiter. If I want to serve more tables, serve more customers, by setting this number higher, what I was thinking is that like, okay, maybe like there's going to be more chef cooking, so everything is faster, right? But what this actually causes is that we are just adding more tables. And if you only have one waiter, adding more tables doesn't really like speed things up, right? In fact, it does slow things down, because let's say if your waiter have to go to one end to serve like one table and then you have to go to the other end and then you have to go everywhere, it's actually like much slower and it's way suckier of an experience. So the correct solution in this restaurant scenario will be okay to add more like waiters, and this is something that we sort of have to learn it the hard way. So yeah, I think go read your documentations. I think they are very important. Okay, so the next part is whether, I think this is something that also something I thought a lot, I think a lot about, like when should we write tests, right? Because in school you probably say everything has to be 100% test coverage, but we really have time for that. And because the time taken to write tests means time taken not to do something else, right? And I think especially if you're trying to build something fast, sometimes you don't even know something will work, or some people really want to use the product, so you're going to build like write tests and do everything very well, and ends up nobody give a shit about your product, and that's not going to be useful. So for us, given the nature of this like our situation, we only write tests for those situations. One of them is when there's too many manual things to test. So one of the features or one of the services that we have is actually like taking a resume and then passing it and then taking all the keywords in the resume. Right? So, and resumes comes in a lot of shapes and forms, and there's a lot of like funky way to write a resume, and there's a lot of edge cases. So for example, right, let's say you want to look for whether this person has the keyword like React in their resumes. Some people put React.js, some people put React space JS, some people put like React JS, some people put React dash JS. There's a million variation of that, right? So if every time I actually update this like code and I have to go manually test this like 1,000 variations, it's too slow. Like it's just impossible to like start building. So in that situation, writing tests actually does make you faster. So that's one of the situations write tests. And so a second situation to write tests is that this code could potentially be a disaster, right? And how I thought about it is that like if this code goes wrong, like what is the like fuck my life metric that I'm looking at? Because like if it's going to be like disastrous, right? Then of course you should write a test. Because for example, you try to fetch like resume data for one user, you want to show it to another user, and because there's like privacy and stuff, right? So those things you better go write your test. Yeah, but there are some other things that don't really like. It's okay to have some like margin of error. So perhaps you don't have to write tests for those things. So of course, I think back to the first few slides, I think this really depends on context. Because today, if I'm building like I don't know an aeroplane system or like I'm building like a healthcare system, of course you need everything to be like fully tested. But yeah, I think it really depends on context. So I think at this point, generally that I'm going to talk through very fast is that there are a lot of free like libraries, packages, tools out there that really can help you get off the ground very fast. You don't really have to pay like a huge amount to like Datadogs or whatever just cause like Facebook users it, right? And you don't need to have like multi I don't know like I can't think of a very good example, but you don't really need a very like production grade like stuff for a lot of things. It's most of the time to get off the ground, all the free stuff does get you really far. So I will skip through this. Yeah, so I think that's the end of my sharing. I think I mean I hope it's useful. How do you waste your like Friday night? Yeah, but before I end off, is there any questions on the ground that I can help with?
So I saw a mistake that was about the max threads. So I saw a slide that says the Rails max threads was the wrong choice. Then what was the right way to solve that?
Yeah. So I think the question is that okay, like I fucked up by setting the wrong like Rails max thread kind of like variable, right? So what's the correct way? So the correct way is kind of like thinking, okay, if you put it in the restaurant sense, that one server can only serve 10 tables in one go. So if you want to serve 100 tables, you need like 10 servers. So for us, is that equivalent is that instead of having just one processors, we probably need to have like 10 processors to achieve that. And it could be done with a few different methods. One is that if let's say the CPU, the machine that you are using have like multiple CPUs, then maybe each CPUs can be like used for like each process. Or it could just be that I could have two separate machines altogether that I can scale up and down based on like the traffic. That's answer. Yeah, any other questions? Oh.
I guess like as one person, and working on like a product where like I guess you have to like move pretty quickly. Like did you have like a specific strategy on like dealing with like tech debt? Like every 2 months you try to review it or something like that?
Yeah, so I think that's a very good question, right? Technical debt. And I think the general approach that we go about solving tech debt is that first of all, we don't try to incur tech debt that are irreversible. So what are some examples of those is that maybe you design your database schema incorrectly, because that's going to be a pain in the ass to do, right? But most tech debts are reversible, and generally the kind of approach that we use is that if we start duplicating this code in like more than 3 areas, maybe it's time to refactor that. And also I think it's more of an art. It's more of an art than science at this point, because even if something has like duplication, if you kind of know that this module is not going to be touched on a lot, then maybe you don't have to like refactor that. But on the contrary, right, even if this thing is, there's no duplication, but you know that every single part of the, like, this is something that you change a lot because there's a lot of change in like product requirements and stuff, then maybe you kind of want to like write it a bit better, so that when you change every single time, it does not slow you down. So I don't think there's a hard and fast rule in terms of that. Yeah.
If you don't mind sharing, what made you choose Rails and what made you stick to it?
Yeah, what made me choose Rails? So I wasn't the original technical founder of the company. I have another co-founder. So that was the decision made. So I wasn't involved in making this decision. But on hindsight, will I choose Rails again? In the context of this app, yes, because Rails app itself by itself is kind of known to be like a one-man framework kind of thing, because a lot of things and like come straight out of the box. It works really, really well. And also I think the community is quite well supported, that if you need authentication ID, you can just use it. You don't have to pay someone for it. If you need a clone job or background like jobs, there's like a lot of like libraries that comes in there. So you are kind of like, your time is actually spent on like building things rather than figuring out how to make things like come together. But that's in our context, right, where the website is not like the kind is like super interactive that it has to be really cool. But let's say today your website is something that you have to be so real time, like, and when users move through the app, like there's this cool like front end shit that's going on, right? Then maybe you choose something that is more like JavaScript focused or like TypeScript focused. Or if you're doing something that like the concurrency or like the latency is like so damn important, right? Maybe go with something like Go or whatever. But I think for us, if you look at a lot of websites are like web apps, and so in that case, it really doesn't. I guess at some point it is really your preference, because even if I say that Ruby on Rails is good, but if someone else they don't have anything with Rails, then they're still gonna be really slow. So like end of the day, I think what kind of realized over the years is that two things, right? I think every frameworks and like language skills, to a large extent, like even like Shopify or like Stripe or like GitHub, those use like Ruby on Rails until a very like late stage. So like if you talk about like Rails don't scale whatever, you're probably not gonna face that problem. So that's one thing. And I think the second point is that like ultimately users don't care about what technology you use, and they don't care about whether you have tech apps. They don't care about whether like you use the latest like libraries or language or everything. Like users really don't give a damn about everything, right? So they really care about, does your product really solve the problem for them? So if someone is like really good with like PHP or like whatever, right? And they can ship really fast and really good with that, then yeah, so be it. Then that just use that asset.
Then, isn't it the case where you're not really saying that, you just, use Rails? It's more like, just be good at, just be good at programming.
Yeah, so I mean, I think forgot the name.
Joshua.
So Joshua.
Yeah.
So Joshua brought a very good point. So maybe it's a question about not choosing the correct framework, right, and just being very good at programming. The answer, unfortunately, is yes, because like there's a reason why your bank engineers get paid like a lot more than like some other companies, right? So being good definitely helps a lot. But I think if you're talking in the context of if today someone's going to start from scratch, from nothing, maybe using something that is more complete, feature complete, that does help a lot. Yeah. That's the observation.
Not more like as on to it.
Yeah, because
Like there's also the issue of choosing what framework or what tech stack you want. But I think this presentation goes before that, where if you just suck, doesn't matter what tech stack or framework you never.
yeah. So if very good point, you just whatever framework language you use, it doesn't matter. It's a you have a skill issue and you just not gonna make it. Yeah. But I think in the context is that if you have a choice and you choose something that work for you lah. Yeah. Yeah. Sorry. Okay, let's just start from the left.
So earlier you said that because you didn't work in big tech before, you have to relearn some mistakes, right? So let's say you had worked at big tech before co-founding a startup, what would you have done a lot differently?
We probably would have fucked up a lot quicker because I think a lot of the practices in big tech works because they are for big tech. Like let's say that your big tech, maybe your Google and like your Facebook, they use microservices because like, every team can use their own like tools and frameworks. And you think, okay, maybe I should use microservices. But that's not going to be the case. It's going to slow you down. Or maybe the big tech, you need like 100% test coverage. It's not going to be a little bit applicable to you. So because sometimes that, well, maybe this thing is going to have an error, but like whatever, like even if it works for 99% of the people, that's good enough. Or even in a very crude way, right? Like maybe your big tech, they say that okay, every app needs to be like accessible like to every single user. You have to have like even no matter whether someone have like they have eyes, they have no hands, everything, they should still be able to use the app. But maybe in a startup, you just don't have the resources to make sure that to cater to every single one. And it's not great, but I guess it's just a hard truth that you can try to make it like really good for every single person, but nobody's gonna use the app, or you can try to put the effort into like try to experiment more. So yeah, so kind of anti-climactic, but I think I might actually not make this work. Yeah.
I'm just curious, how did you deploy the website? What do you use to deploy it?
Yeah, so we also don't really have like a full CI/CD pipeline. We have CI, but so what happens is that let's say that something passed in CI, I manually run a command in my console and then deploy it. Yeah, and before that it was even more ridiculous, right? Because before that we were using like Elastic that have been stored on like AWS, and then I have to manually export the files into a zip file and upload that zip file and hope that it deploys. But once again, it works.
Is there like downtime when you deploy it?
No, so generally there is no downtime. So I mean that it depends on configuration, but I think most of them comes in the form of like you make sure that your new servers like is up and running. Maybe pass a lot of like checks before they roll over. Yeah, so there's a few deployment options also, but most of the time there's no downtime. Any more questions? Yes.
So you mentioned cutting down the egress cost from the server to the database. Like if you move the database to the same provider as the servers, I think there wouldn't be any egress cost. So have you considered that?
It depends also. I think that's a good point. But it's not always going to be the case. Yeah. So I of course I think there's going to be cases where maybe you host it in the same like VPC or whatever, and then they don't charge you. But the downside of that is also you are limited to that provider for everything. So for us, we were using AWS for everything, like Elastic Store, RDS, Elasticsearch, and everything. And that was also one of the reasons because everything is in the same place, so it's easy. But we kind of realized that, well, AWS was very good at like Postgres. They are pretty expensive in terms of the compute for the servers. So do we then decide that, okay, do we want to be locked into overall not so great experience, or do we want to take a bit of the pain but do some stuff to make sure that everything else you are using the best of everything and not get locked into one provider? Yeah, so that's also one thing to consider. And I think another thing to consider was that we were using AWS for a big part of the things, but when something broke, because like the nature of like AWS businesses where they focus on the bigger companies, they don't really provide support for the smaller companies, or you have to pay for support. So the question is that, okay, do we then deal with that kind of like lack of support or very poor like DX kind of situation, or do we then choose something else? I mean, of course, there are situations where it makes more sense to go with AWS. For example, let's say you are a much bigger critical system and you really need something that is like production grade and tested. But yeah, I think in most cases, especially when you're smaller, it doesn't really matter as much. Yeah.
One question about egress. Do you compress the pages instead?
Yeah, so we do compress them. And I think even if you are using Cloudflare, you should be able to tweak some settings and they compress them. Yeah.
A question about Rails, because Rails is quite opinionated. So like how often do you do things the Rails way, and how often do you find like you have to break out to just like do it your own way?
Yeah, good question. I think Rails being opinionated is a pros and cons, and I think really depends on, once again, to your use case. So Rails have this thing where they don't really like to use like front-end frameworks like React and everything else. And they have this thing where it's called like Turbo, where it's like their own way of dealing with front-end reactivity stuff, interactions. But I think for us, we are in a situation that we kind of always have like interns joining the team. And do I want to go to this like more proprietary like kind of like framework, or do we want to choose something that's like React, where most interns kind of know React, or even if they don't, it's very easy to pick up. And so it's not the Rails way, but in our context, considering beyond the technical aspect, but also the organization kind of situation, it does make sense to not stick to Rails like way of doing the front end. Yeah. Okay, no more questions. Okay. Very good. Yeah, thank you very much. Enjoy your Friday and weekend.